We're going to talk about solving proportions, which is one of the simplest things we're going to do in algebra, but it seems to be one that students are always confused by. So I want to take time to really look at why we do what we do when we're solving a proportion. I see a lot of incorrect steps and incorrect application of techniques when students are solving proportions, and so I want to make sure that we're very clear about what we do with these. So what's a ratio? Let's review from last year. A ratio is a comparison of two numbers. You can write it as a fraction. That's the most clear and mathematical way to write it. And then a proportion is a comparison of two ratios. So essentially you have one ratio equals another ratio. So let's talk about what this means. This is a fraction, so this is a division problem here, and it's equal to another division problem there. And so if you're trying to solve it, I'm not saying that all four of these are variables, I'm just saying that this is something on the top and the bottom and something on the top and the bottom. We don't know what it is. But let's just think about this from a concept point of view. If we have a division problem equals a division problem, then what do you think are the steps, the inverse steps that you would have to take to counteract or to do the opposite of a division in a division? Well, the opposite of division is multiplication, and so obviously if you're trying to undo this division and undo this division, you're just going to be multiplying here or both. So cross multiplying, and I've written this in colors here, and you'll have to excuse the ink smudges. I didn't realize some of the ink was still wet when I was rubbing my hand over it. So A over B equals C over D, and just remember that I have an equal sign in here, okay? Right there. So you cross multiply by taking the B and multiplying it up here by the numerator of the other fraction. And the same thing with the D. It comes up here to the numerator of the other fraction, and they're multiplied because, again, we said we're trying to do the opposite of this division that's already here. So the opposite of division is multiplying, and since we have division here and division here, we're going to multiply here and here. Make sense? And so what I'm going to have there is I'm going to have A times D. If I'm bringing this up, I'm going to have A times D, which is here. And then if I'm bringing this up right there, I'm going to have B times C, which is here. Or CB, it doesn't matter because of the commutative property we've already learned. So let me ask you a question right here. What is the difference between this and this? And I know it's a simple question, but I really have to just harp on this for a second. Okay? This is an equation. This one here is an equation. So since it's an equation, that means that it's a proportion. See? And so cross multiplication may apply. Sometimes you don't need to, or sometimes it works against you if you do. But it may apply because it's an equation. This is not an equation. This is simply multiplying two fractions. So you have a fraction, which is division, obviously, but then you're just multiplying it by another fraction. This is just multiplying, and so your regular multiplication rules apply. We're not doing any cross multiplying for this scenario because it's not a proportion. Okay, and you can only cross multiply when you have two things that are equal to each other. So, now that we've cleared that up, let's go through this problem. Notice these are both equations now. I'm not trying to trick you. They're both equations. It's the same equation. I've just written it down twice. And I'm going to show you how to solve for n. And remember here, we're trying to solve for n. Okay, that's the variable. We're trying to solve for that. But I'm going to do this two different ways. I'm going to do this a not paying attention way, and then I'm going to do it a more careful way. So just follow me as I'm going through this, okay? So let's say, okay, all right, I know how to cross multiply now. I take each denominator and I multiply by the opposite numerators. So I bring the d up and I bring the b up. So if I do that down here, that means that I'm bringing the 10 up there and I'm bringing the 8 up here. Okay, so now I'm going to have on the left-hand side, I'm going to have 10 times 10, and on the right-hand side, I'm going to have 8 times n. Okay? So all I've done there is I've just taken this denominator and I've moved it up, and then I've taken this denominator and I've moved it up to the other numerator, right? The other numerator through multiplication. Okay. So let's do this. So here we have 100 equals 8n, and now if I still want to solve for the n, you should realize by now that we're just going to be dividing by 8, and I'm going to get n and 50 over 4, or 25 over 2, I should say, excuse me. 25 over 2. 25 over 2. Okay, which is 12 and a half. Okay. 12 and a half there. Okay. But I have made this more complicated than it needs to be. Because what was my blue step right here? My blue step was multiplying by 8, because essentially what I'm doing here is I'm saying that I'm multiplying both sides by 8. And here is where it crosses out. Those cancel. And then here is where I get the 8n that I wanted. Okay, because those are now being multiplied right there. So that is why cross multiplication works. But look what I've just done, right? So here I multiplied by 8, okay, and then what do I have to do right here? I have to divide by 8. These two steps are the exact opposites of each other. So really what I've done is I've just added in an extra step, and I don't even need to, because I wasn't paying attention. Let me move that out of the way, sorry. I wasn't paying attention. So let's do this again, being more careful. I know that I am trying to isolate n. That is what I want. And so I can ask myself, like we did before, what is happening to n? It's being divided by 10. There's no other n's in this problem. Nothing else is happening to n. The only n is just being divided by 10. So we know that if that's the case, then all we need to do is multiply by 10 and multiply by 10 on both sides. And so these would cancel, okay? And so then on the left, I can I can even multiply across the top and get the 100 over 8 that we had that we had over here. Or I can take an opportunity and just reduce, and I can say, okay, well, 2 goes into 10 5 times, and it goes into 8 4 times. And so then I would have 50 over 4, and then over here I'm just going to have n, and so then I can still reduce that and get the 25 over 2. So the reason that this is better is that I've only done one step. this is essentially just a reduction step because I did all that right there. So I did all that I needed to do in one step here just by being careful rather than doing 1, 2, 3 steps. You see the difference? Okay. So let's go through some examples, shall we? Let's go through some examples. Okay, so here, and I'm going to take my highlighter and I'm going to highlight the variables here so that we're all aware of where they are, because sometimes they can be sneaky and sometimes you don't see them. So here is the variable pardon me, here's the variable in this problem, here's the variable in that problem, here's the variable in that problem, here's the variable in that problem, and I'm just going to stop there for right now. Okay. First thing you should notice is that we can never solve for a variable if it's in a denominator. It just doesn't work. So we can cross multiply, and I'll actually show you a different technique over here on this one, which I like even better. We can cross multiply, and I need to get this up here, right, so that it's in a numerator. But I also need to get this 7 out of here because then I'm going to have n up here. I'm going to have, see my little imaginary n after it comes up there? And then I need to multiply by the 7 to get this out of there. So I know that also I need to do this one. In this case, I have to do both. Okay? And so when I multiply 7 times 7, I get 49 over here. And then when I multiply n times 8, I get 8n. Okay, and so just to be clear, I'm going to pull this out of there just so we're not thinking it's 2 n's. And so now I need to divide by 8, and notice I have not multiplied by 8 at all, so I'm not undoing any of my previous work here. And so I get 49 over 8 is my answer, and this will not simplify, I don't believe. So there is my solution. Okay. Now here you could do the same thing on this one as this one because they're, as you can see, they're very similar setups. I'm going to do a trick on this one, and I'm going to do a special technique that is called going to reciprocals. Going to reciprocals, and that is a fun technique when you're dealing with stuff in an equation setup. It has to be for an equation. And you just essentially take the entire equation and flip flip everything. It's really easy for this kind of scenario where you have fractions, and so you can just go through and flip all of these to their reciprocals. You have to do both of them, otherwise it's not correct. And the reason you could do that is this is the same as taking the inverse and saying 1 divided by both of these sides. So if you want a more detailed explanation, come talk to me later and I'll explain it to you. So if we go to reciprocals, then we have 3/4 equals x over 8. And now notice that the only thing that's happening to the x right here, the only thing that's happening to the x, because we're still trying to find that guy, right? The only thing that's happening to the x is division by 8, and so I can then multiply by 8 up across, okay, which is the same as multiplying by 8 on each side. I could write this, or I could also write 8 over 1 and 8 over 1. Either one you want to say is fine. And so, but just to be clear that we're not doing it twice, I'm going to erase this part, okay. So we're just cross multiplying the 8 up to the other side, and that's going to leave me with the x by itself. And so what I have over here is I have 8 times 3 is 24, and I still have the 4, and that equals x. But I know that 24 over 4 is actually 6. So there's my answer. Okay, that simplifies. Here's an example where we have this business that's locked in, and you've heard me say this before. This is locked in here because the addition, this addition, does not commute with the division there. So b plus 5 is a little package that's locked in. And so if we want to get this out of here, we can do one of the two things we did up here. And I'm going to do this using this first method here, where we cross multiply both. Okay? Either way, it's really the same number of steps. So we know that we need to get this up here, and we know that we need to get this up here because I'm trying to solve for the b. So if I don't multiply the 5 up, then I'm going to have to do it later. So I might as well just do it now. So be careful and remember that when you're cross multiplying, you are in fact multiplying. Okay? So 7 times 5 is 35. And I say be careful that you're multiplying because really what we're doing here is we're taking 10 from the numerator, but then we're multiplying it by this whole package, and so we have to distribute there. Do you see that? But we don't necessarily have to distribute yet, because in fact what we could do to make our lives easier is just go ahead and divide by this 10. But just be sure that you're saying 10 times the whole b plus 5 group, okay? So if I multiply by the 10, then those go away. And I'm going to have, let's see, if we reduce this by 5 on each one, so this becomes a 7 and this becomes a 2. So this is 7 halves equals b plus 5, and now we have to subtract 5. But we have to subtract 5 in a way that will work with the 7 halves we already have over here. So we need to actually subtract 10 halves, which is 5, okay? And so then those go away, and we're left with b equals 7 minus 10 is minus 3 halves, okay? 7 minus 10, okay? I do this right, 35 divided by 5 and 10 divided by 5. Yeah, it looks right to me. If I've made a mistake, just call me out in class. Okay, here I've got the r already in the numerator, so what I need to do is I just need to get rid of the 6. And so we're going to have 6 times 4 is 24 over 9 equals r minus 3, and so I need to add 3 and add 3. But I need to add 3 so that it works with this 24 over 9. I need a common denominator, so I need to actually add 27 over 9, okay? Because 27 over 9 is 3. And so these go away. 24 plus 27 is 40 or 51 ninths. And this actually will reduce by a factor of 3. So if I divide this by 3 and I divide that by 3, then I'm going to get 17 over 3. So there's my answer. Okay? Okay, so here we've got a scenario where we have an x in 2 places, but we can't deal with an x in the denominator. So the first thing we need to do is just kind of rework this so that it's more manageable. Okay, so we know that we need to get the x up there. And if I'm going to have an x up here, then I know that I can't have the 10 down here. So also the 10's going to have to go up. Excuse me for hitting the camera there. So here we're going to have 10 times x minus 3 equals 9x. And be sure that you realize that I have to distribute here and here. Okay? That's why we're doing it that way. So 10x minus 30 equals 9x. And now I can actually deal with getting the x's together. So I'm using inverse operations right there, and I'm left with a negative 30 equals 9 minus 10, which is a minus 1x. Okay? And so then if I'm dividing by negative 1 and dividing by negative 1, I have that x equals positive 30. Alright? So now we have a really big mess. We've got variables in both denominators. Okay, and so we need to bring this up, and we also need to bring that up. There's no question about that because we can't solve for those variables if they're stuck in a denominator. So here we have 5r plus 5, and here we have 8r minus 9. And so unfortunately we just have to distribute both places. So we have 5r plus 25 and 8r minus 72. So I'm just going to subtract the 5r to keep the r's positive here. And so we have 25, and we have 8 minus 5 is 3r minus 72. So now I need to add 72, and I'm sorry, I'm cockeyed here. So add 72, and so then we're going to have 3r, and over here we're going to have, this is a 97, and so then dividing by 3, and I should know what that is off the top of my head, but I don't. 97 divided by 3 is something whole. Oh, it's 32 and a third. I'm sorry, it's 32 and a third. So 32 and a third. Excuse me, 32 thirds. Oh my goodness. No. 97 thirds is the correct answer here. I'm just going to leave it as an improper fraction. I like improper fractions. 97 thirds. And I've got one more example to show you right here. So here we've got a variable in the top and bottom, so we definitely know that we need to get that out of there. But then we're going to have this 2 on the bottom, so we kind of have to end up getting that out of there. So we're going to have 2 times n minus 6 and 9 times n minus 7. Okay, so if we're distributing here and here and here and here, this is 2n minus 12 and 9n minus 63. And so then if I subtract the 2n, I can keep the n positive. So this is a minus 12, a 7n, and a minus 63. So now I need to add 63, and I'm going to get a 7n, and 63 minus 12 is, what is that, 51, right? 63 minus 12 is 51, and so then I got to divide by 7, and I don't think 51 divided by 7, yeah, that's irrational. So n, because these now cancel, and those cancel, and those cancel. Okay, and so this is 51 sevenths, and there is my answer.